Of course we should care about energy, but at the same time we should also be thinking about people's health inside of buildings. And so we need to be developing strategies that address both energy use and indoor air quality. It turns out that an interior designer has a lot more influence on our health than our doctors do, for example. So my name's Jeff Siegel, and I teach and do research at the interface of building science and environmental engineering. And predominantly here, I do my research in the building science lab. And almost all of my research and teaching focuses on the indoor environment, especially indoor air quality, but also energy use of buildings. Okay, so we're here in the building science lab, and what we study in the building science lab is both the energy conservation and energy use of a building, as well as the indoor air quality in a building. And so I think that the wave of the future is and should be, of course we should care about energy because of the energy resource consequences that we face, but at the same time we should also be thinking about people's health inside of buildings. And so we need to be developing strategies that address both energy use and indoor air quality in buildings. So here we have a big space, one half of which is a cold room, one half of which is a warm room. And so we can look at the energy transfer that goes on between a building assembly or some other component between the two of them. Basically, I'm interested in the indoor microbiome, the fungi and bacteria that exist indoors. And they're ubiquitous, they're everywhere, and what are the factors of a building that controls their populations and which species exist. Most of my research deals with indoor particles. So all around us there are millions in this room, millions of particles, so small that the eye can't see them. They're very important for our health, and so I study how they get there, where they come from, and what we can do about them. What kinds of control technology, for example, filtration, we can use to address those contaminants. So I mentioned that particles are ubiquitous in the indoor environment. They're really everywhere, and they span in size range from a nanometer or a fraction of a nanometer. So we're talking about some particles that are just amazingly small, not that much bigger than a molecule, and then other particles, they span over 7 or 8 orders of magnitude in size. So this huge range, up to particles that we can see with the naked eye, pieces of dust, things like that. And so one of the big issues in studying particles in the indoor environment is that there are so many different sizes. They all have different behaviors inside. They all have different sources inside, and they all end up in different parts of our body, ultimately different parts of our respiratory system. And so part of the fun and part of the challenge is understanding these different sizes of particles and what they mean for our health. I think a very important point to make is that Canadians are indoor creatures. We spend about 90% of our time in indoor environments. We spend about somewhere between 2/3, maybe 70% of time in our homes. So anything that exists in the air inside buildings, we're going to be breathing in. And in fact, if you look at everything we take in over the course of a day, what I call environmental fluids, soil, air, and water, by about a factor of 10, we breathe more air by mass than, for example, we drink water. And so a contaminant can exist at much lower concentrations in indoor air and have a much more serious impact on our health. So we should all care about indoor air because we're breathing so much of it. Another way I look at it is from a risk perspective. If you think about the things that are likely to cause us sickness, a very high fraction of those things are things that we breathe. Especially breathe indoors. And so a big part of our risk for things like lung cancer, for example, come from things we breathe indoors. There are many green building programs that seem to address indoor air quality, LEED being one example of them. The problem is that indoor air quality as a science is very much in its infancy. So a lot of things that we think we're doing for indoor air don't actually address indoor air that well. Some of that is lack of knowledge. And some of that is we don't even know necessarily what contaminants we should be addressing. So let me give you an example. There is one class of compounds, semi-volatile organic compounds, or SVOCs. SVOCs weren't really on the radar screen as a health risk 10 years ago, certainly 20 years ago. And now they're turning out to be a very important health risk. Another example is particles. I mentioned particles span many sizes. The old standards in Canada and the US and much of the world were what was called PM10, particles that were smaller than 10 microns in diameter. It turns out that all the new standards address PM 2.5, particles that are smaller than 2.5 microns in diameter. And it turns out PM 2.5 is much more important for our health, but we didn't really have the instrumentation and as much ways of measuring those smaller particles previously. So as we've discovered more, we realize, oh, these are really important for our health. And so it's still very much evolving what we should care about and how we care about it. One of the things I mentioned earlier is that I'm interested in the indoor microbiome. You know, we are all essentially hosts for bacteria. You have 10 times as many bacterial cells in your body as human cells. There's all these bacteria all around us. Most of them are good or benign. Very few of them are bad for us, and they're everywhere. So if we were to take a microscope and look at the surface of this desk up close, it would be crawling with bacteria, fungi, and other things. And again, this is not bad. Many of them are in fact quite good for us. Another statistic that's kind of interesting is that we have about 1 trillion bacterial cells in our bodies. And so what happens is we exchange those microorganisms with all the surfaces in a building around us. So right now, the reason I'm wearing gloves is because I have lots of bacteria, so when I point to things on this slide, I don't want my bacterial community to influence it. I'm working with some microbiologists, and we decided we wanted to study the indoor microbiome and study what factors in a building and what factors in materials influence the community of microorganisms that are inside. What I did is I designed these plates that you see before us, and basically a plywood plate with 9 holes in it. And each of the holes has one of 3 different building materials: carpet, drywall, and ceiling tile. And the reason we have these building materials is they're common building materials, and we want to see over time how the fungi and bacterial community develop. Every couple of days, these plates are going to be installed for a year in different cities around the US and Canada, and in different locations within the city, all office environments. And every couple of days we'll come by with what looks like a Q-tip essentially, and we'll swipe these surfaces. Then we put that Q-tip in a sterile container and send it off to one of my collaborators who does DNA extraction from that. And they look at the actual chain of DNA from all the microorganisms that collect on that swab. And then you take all those DNA chains and compare them to a big database to see what organisms you have. I'm not a microbiologist. What I am is a building scientist, and I want to know what factors in the building influence the growth of those microbial communities. So what I've done on the plates, independent of the biological sampling, is put a bunch of sensors. These sensors here are measuring water activity. And water activity, you can think of it as kind of a surface relative humidity. It's how much moisture is available to those microorganisms. One thing we might hypothesize, for example, is that in an environment or a material that has more water activity, we might see different microorganisms in an environment that's drier. Something called human-associated bacteria, those are bacteria that come from us ultimately, end up covering the surfaces in buildings. This device here is an occupancy sensor, just like you would have in a security system. We've modified it a little bit, and what it does is it tells when someone comes near one of these plates. This is measuring temperature, relative humidity, and light. All things that maybe influence the microbial community. That's one of the things this project will find out. So we do a lot of other measurements as well, an example of which is these microscope slides here. They're just ordinary microscope slides, and what happens is we clean them before we put the plate out, and every month or so we come along with a piece of Scotch tape, put it down, peel it up, and look at that tape under the microscope. And the more dust that's in an environment, the more dust will appear on the tape. At the end of the day, all of these are going to be mounted on floor, wall, and ceiling, and all of the backs of the material have to be pressed against the surface that we're measuring. If I was the king of the world, I would cut a 2 by 2 foot hole in the wall and put this in place, but people aren't going to let me do that. So our next best thing is to have all these at the same level. And in fact, the thing we're working on in the lab right now is trying to get the drywall to be just a little bit more flush with the surface. So we're obviously in a bathroom, and you might think, why would we want to spend time in a bathroom? Well, the reason is that it's a very kind of common indoor environment that I think a lot of people don't give a lot of thought to the indoor air quality in a bathroom. So for example, we're standing in front of some urinals. Very often, urinals will have a urinal cake in the bottom for deodorization purposes. Very often, they're a white puck, looks like a hockey puck. That is paradichlorobenzene. It's a deadly carcinogen. It is certainly on the top 10 list of things that are likely to cause cancer that we breathe indoors. And they're ubiquitous in bathrooms. Well, because they have health effects, over the last few years, I've noticed, especially in Canada, people moving away from paradichlorobenzene urinal cakes, and you see sometimes blue-colored urinal cakes. They don't have paradichlorobenzene in them, but they have a bunch of other things, many of which are, not really that well known, that also have health effects. So you think the simple idea of we want to deodorize a toilet, that's obviously something that's important to do in public bathrooms, but it has a very profound impact on human health. And to give a specific example of this, we have a paper that came out a few years ago that shows that the Hispanic population in the US has a very severe cancer risk from paradichlorobenzene. And that cancer risk comes from the use of toilet bowl deodorizers, for whatever reason, is more prevalent in the Hispanic population in the US. You can go to a store and buy a product for cleaning your bathroom, buy a very green, eco-friendly product, and it itself might be quite harmless. But it can react with other things, either in the cleaning process or other things that are just in the air, and form a whole lot of hazardous things as a background. So we have an issue from the perspective of kind of casual exposure, and then we also have the issue of course, occupational exposure. And these are both very serious issues, and obviously I'm not suggesting don't clean a bathroom, but the other idea is we are also introducing risk by cleaning and looking at the cleaning products we use. So we're standing in front of a public toilet, and why again should we care about public toilets? Well, I want to show you two things on this toilet. The first thing is you see there's no lid on it. That's very common in public toilets, and it's done for hygiene and cleaning reasons. But you can imagine when a toilet flushes, there's a tremendous flow of water. It's amazing hydraulics, actually, and a bunch of that water gets aerosolized. What's in the water gets aerosolized too. So there's tons of bacteria, potentially infectious disease, other things that are coming out of that toilet bowl into the air. Those are all things that we breathe in if we're in a toilet, as well as think about things like all of us at home keep our toothbrushes out in the open, flush the toilet, it's getting covered in the bacteria and everything else from the toilet. And so one of the very simple things you can do from an indoor air quality perspective, I'm not sure actually how important it is, but it's really easy to do, is keep your toothbrush covered when you're inside. But in any case, the reason I think about this, the reason I want to do this in a public toilet is we all know people who are very careful not to touch any surface in a public toilet. They use paper towel to open up the door. They use, don't touch any of the knobs for turning on and off the sink. But the bottom line is that's okay, that's important from a hygiene perspective, but we're breathing in a ton of bacteria and other things from the toilet.
This probably won't go in, but where do you keep your toothbrush, just like in a cabinet?
Yeah, in a cabinet. Sometimes there's kind of the toilet room is kind of compartmentalized. It helps a lot if you shut the lid. If I was really concerned about it, I would you can get like a ventilated toilet where the headspace above the toilet is ventilated to the outside. You see those in some public bathrooms. So we think about something like Toronto with SARS. That was kind of completely neglected. SARS, in fact, originally started from exhaust from toilet. That's one of the vectors by which it spread. The other reason I wanted to point out this toilet is that you can see there's some toilet paper over the sensor for the automatic flusher. The reason why someone does that is if you've used these toilets, they flush all the time, when you're sitting down, when you move a little bit, everything else. So they're far too sensitive. The reason those sensors are there are water conservation. That's a very important issue, especially in some places in the world. But you think about, we're saving water by having one of those sensors, but at the same time, if the toilet is flushing a lot, especially when someone's right there using it, they're getting exposed to a ton from the water. And so actually blocking it like this, someone does it because they don't want to be annoyed by it, but it's actually to a certain extent protecting them from frequent flushing and frequent aerosolization of droplets. Well, the problem is that a lot of these drops, depending on their size, are airborne for a long period of time. It can be for the smallest size droplets. Droplets are also funny because they exchange moisture with the air, so they change in size. But it can be hours in some cases, but certainly minutes, depending on their size. And not all those droplets contain infectious agents, of course. And it's a lot less serious in a non-public toilet because a much smaller number of people are using it. And, I'm not suggesting not using toilets, because obviously they have an enormous public health benefit, much, much greater than any indoor air decrement. But it is, we should be aware of that fact. If you care enough to, use paper towel to make sure you don't touch any surface, and are very, you've got a dispenser for Purell on the wall here. If we're caring that much about it, we should certainly be considering the airborne route. It's enormously important. Very high on the list of indoor air concerns for a lot of people is cooking. Cooking generates an enormous amount of harmful pollution, like just amazing amounts. Doesn't matter whether you're cooking gas or electric. It does matter. It's different amounts and different kinds of pollutants, but it's still a very important pollutant source. If you're frying something or doing other kinds of cooking, you generate a bunch of pollutants. And so one of the best things people can do is ventilate, use their range hood fan or actually ventilate their kitchen area. So the point I guess I would make is there's a lot of really mundane stuff in buildings that is exposing us.